We have all wondered the same thing at some point in our lives. Is there other life out there in the universe? And if there is, why haven't we found it yet? This idea is often expressed as the Fermi paradox, a theory brought forward in 1950 by physicist Enrico Fermi that states there is a paradoxical relationship between the lack of evidence of alien life and its probability of existing. With all the trillions of stars, theoretically, there must be some form of life out there lurking in our universe. So why haven't we seen it yet? And are we truly alone in the universe? Perhaps we aren't alone. Extraterrestrials may be hiding in many places around the universe. We just don't know where to look for them. Life much less complex than our science fiction depictions of aliens may exist in the abundance around the universe. Or perhaps advanced alien races have been hiding in plain sight all along, waiting and watching. Whatever the case, it's up to us to find them. So here are 5 areas of the universe where life could be hiding. Sit back and enjoy. Enceladus. One of the first places where life might be hiding might be under our noses, right here in our own solar system. Certain moons of Jupiter and Saturn have been identified as some of the most likely candidates for harbouring extraterrestrial life. Satellite missions to Saturn and Jupiter have analysed the moons of these planets to observe their chemical composition and environment. They use these points of data to extrapolate how habitable these moons would be for any sort of life form. Of the analysed moons, one of the most promising was Saturn's moon, Enceladus. If life exists on Enceladus, it wouldn't be found on the moon's surface. The moon is covered by a massive sheet of clean ice, estimated to be nearly 40 kilometers thick. Temperatures on the surface only reach minus 198 degrees centigrade, far too harsh for any sort of life that we know to exist. Although these initial exterior observations seem to suggest life could not exist on Enceladus, scientists soon discovered that life may be flourishing somewhere else on the planet, its underground oceans. In 2005, the satellite Cassini, sent to study Saturn and its moons, relayed back information that would ignite the scientific community with excitement. Vast plumes of water were being ejected from Enceladus' south pole into space. These plumes were found to be what composed Saturn's E-ring, but more importantly, they were a clue to the possibilities of life brewing below the surface of the moon. These jets of water vapour suggests that there is a liquid water ocean below the ice sheets. With the vast amount of water present on Enceladus, it becomes much more likely that life could be hiding deep below the surface. But just what might alien life from Enceladus look like? Many scientists believe that deep on the ocean's floor could exist chemosynthetic life, very similar to those that exist on Earth. Chemosynthesizers live near hydrothermal vents on the ocean floor, feeding off of the chemicals that are spewed out of these at super hot temperatures. Chemosynthesizers are unlike photosynthesizers, in that they require no light to keep on living. All they need are the chemical nutrients from the vents. These forms of life have adapted to immense oceanic pressure and extreme living conditions, and are often perceived in pop culture to be some of the most alien-like life forms on our own planet. Such life forms could very possibly be living at the bottom of Enceladus' oceans, feeding off of hydrothermal nutrients and living in the shadows, obscured and currently undetectable. Planetary scientist Caroline Porco was the head of the Cassini satellite mission, and throughout its course until its completion in 2017, she has wanted to take the next steps in the search for life on Enceladus. She says such a study would be a test of one of the ideas about the origin of life, and could change the way we view life as we know it on Earth and throughout the universe. They could end up looking very similar to the life forms we see on Earth, suggesting a possible shared genesis for life in our solar system. There's also a chance that the creatures that lurk in Enceladus' oceans are unlike anything we've ever seen before, suggesting life evolved independently on Earth and Enceladus, and illustrating just how plentiful life might be throughout the universe. Scientists have already made a few mission proposals deliberately orientated towards searching for life on Enceladus. The proposed Enceladus Life Finder, or ELF mission, would orbit around the South Pole to collect samples of the water vapour, to understand the interior marine environment more completely. and to see if there are traces of possible life forms living deep below the surface. However, we are still a long way from executing these missions and finding out if alien life truly has been hiding so close for all this time. Rosetta's Comet. On the 2nd of March 2004, the European Space Agency launched the Rosetta spacecraft, with the hopes of orbiting and landing on a comet, more commonly known as Rosetta's Comet. This spacecraft came into the comet's orbit in August of 2014, with the intention of studying the comet in orbit, as well as landing the landing module Philae on its surface. Upon its landing in November 2014, Philae became the first module to ever land on a comet, and commenced its mission to study the composition and behaviour of the comet. This was revolutionary on its own, but no scientist could have anticipated what would be detected. In May 2016, scientists on the mission declared that they had found chemicals which could indicate the presence of microbial life on the surface of the comet. Parts of the crust of the comet were found to be deep black in colour and full of organic chemicals, which some believe were created through the existence of microorganisms living beneath the icy surface of the comet. Phosphorus, an element important to the structure of DNA, was also found, along with the amino acid glycine, most commonly found in collagen, the main structural protein that occupies the space between connective tissues in animals on our planet. The presence of these molecules in such an unexpected place suggests that some sort of microbial life either currently exists or existed at one point on the comet itself. Unfortunately, the lander module was not fitted with the correct instruments to identify if life was truly present on the comet, as it was considered extremely unlikely that any sort of life would be able to survive in the harsh environment of space on this comet. Though the evidence is compelling, it is inconclusive and leaves us with a lot of questions about the comet's composition. If life was shown to exist on the comet's surface, it would change the way we understand how life travels through the universe. This would provide massive evidence towards the theory of panspermia, the idea that life spreads through the universe through natural vectors, such as this comet. Although the conditions of outer space are harsh, we are aware of a few organisms that might be able to survive such brutal conditions. Tardigrades, for example, are microbial organisms that have been observed to be able to survive within the vacuum of space for extended periods of time. Perhaps some hardy microbial organism has taken hold of Rosetta's comet and is lurking just beneath the surface. With the Rosetta module having been hard landed on the comet's surface and communications ended with the module, we will have to wait for another mission for answers. Chappell Ski Star. While microbial alien life might be around nearby, complex alien life might be lurking in our cosmic neighbourhood. 370 light-years from Earth exists a star with unusual energy signatures. Nicknamed Chappell Ski Star, the chemical composition of this star is unlike any other in the universe. In 1961, Polish-Australian scientist Antoni Chabelski began studying the star using spectrometric measurements and observed an unusual number of elements that made up the majority of the star. Elements like strontium, yttrium, cesium, and uranium were observed to be present in large amounts, and even heavier elements like neptunium, californium, berkelium, and even plutonium were found in smaller quantities. These are some of the heaviest and most unstable elements in the universe, and many of them are radioactive. Even more unusual, iron and nickel, elements both typically seen in a star's spectrum, were found in unusually low amounts. Many of these heavy and complex elements have never been observed as part of a star's spectrum, and are hardly observed at all in the natural universe. Stellar fusion just wouldn't produce elements of this size. What could be causing such elements to appear in such large amounts in this star then? Well, two main theories have been proposed about the star. One uses the theoretical motion of the island of stability, a concept stating that when these heavier elements have a magic number of protons and neutrons, they will have a perfect nuclear shell, increasing element stability as the elements get heavier, which is contrary to what usually occurs with nuclear decay. This could explain why these elements are so present in this star, as the half-life for elements in the island of stability can be extended up to millions of years, when their regular half-life would only be a few days or minutes at best. However, this is still purely theoretical, and scientists have no way of knowing if this notion is correct. The other more fascinating theory is that the star is a kind of nuclear waste dump for an alien civilization. Though this explanation may seem outlandish at first, it is entirely possible that an alien civilization would throw such nuclear waste into a star as a way to dispose of it away from their own planet. Perhaps there is some sort of alien society that utilizes the power of fusion to power advanced technologies, and they are able to utilize this star to dump all the toxic and radioactive products of these industries into this star. Aliens may also be making this star radioactive as a form of communication, letting observers from around the galaxy know that they exist through this unique technique. In the book Intelligent Life, Carl Sagan said that aliens might end up salting their stars with heavy radioactive elements, so that observers in the galaxies might become aware of their presence. There is still a lot of mystery that exists behind this star, and many questions could remain unanswered for decades to come. But perhaps one day we might be sending a mission in that direction to see if aliens are truly trying to contact us by way of suns. Planets orbiting black holes. Out of all of the celestial objects in the known universe, few are regarded as more dangerous than a black hole. Black holes are supermassive objects that have become so dense that their gravitational pull prevents all matter from escaping. Objects that enter black holes are thought to be spaghettified, stretched endlessly into the singularity of a black hole. So you may be surprised to know that millions of life-sustaining planets might exist in orbit of a black hole. Czech researcher Thomas Opatany approached this possibility in January 2016, when he and two of his colleagues wrote the paper Life Under a Black Sun. This research was inspired by the movie Interstellar, in which a group of astronauts from Earth utilize a wormhole to explore 4 planets orbiting near the fictional black hole Gargantua. They encounter extreme conditions, such as 1,000-foot tidal waves, on the fictional Miller's planet, as they search for a possible habitable place for humanity to live. But in reality, conditions could be even more extreme. On something as close to the black hole as Miller's planet, Thomas concludes that conditions would be extremely harsh, due to the time dilation caused by the intense gravitational pull of the black hole. Temperatures on the planet could reach up to 900 degrees Celsius, meaning the large tidal waves of the planet's surface would more likely to be made up of molten aluminum rather than water. While these are extreme conditions, it may be possible that a planet in a gravitationally stable position orbiting a black hole could sustain simple and even complex life. Thomas calculates that an older black hole that has absorbed all the hot gases and stars around it could sustain a planet orbiting it, with about 900 watts of power per year. This extremely minuscule amount of energy would likely only allow chemosynthetic life to prosper. However, an advanced alien race may be able to harness the energy of a black hole through the construction of a Dyson sphere. This technology would capture as much ambient energy as possible for the black hole to use, generating as much as 3 times the amount of solar energy our sun puts out. Such an advanced structure would make complex life sustainable for generations. While there may be such advanced alien civilizations lurking around black holes, it would be extremely difficult for us as interstellar observers to determine their existence. Black holes distort and bend light, blurring space around it to observers and making it nearly impossible to determine just what lies in orbit around them. So despite all of our efforts and theories, the existence of life around black holes will likely remain hidden to us for many years to come. Maybe one day we will be as lucky as the space travelers in Interstellar, and be able to use a wormhole to observe a black hole and the objects orbiting it up close. Until then, any life existing near black holes will remain a mystery to us. Rogue planets. Rogue planets are planets without a star, moving through the universe independent of a solar system. Some conspiracy theorists believe that one day all life on Earth could be ended by the planet Nibiru, a rogue planet hurtling through space on a collision course that would bring about Armageddon. But what if such a planet wasn't a life ender, but a life preserver? One of the most fascinating possibilities for life existing in our universe is that it could be flying through space on a rogue planet, eluding our astronomical observation and staying hidden as it drifts through the universe. There are a multitude of ways rogue planets can sustain life. One way is in the form of chemosynthetic life. If a rogue planet has any moons, the tidal heating effect that the gravitational pull of the moon would have on the planet could create liquid water oceans beneath the icy surface of a rogue planet. This would allow for chemosynthesizers to thrive near thermal vents at the bottom of the ocean, but life could possibly exist in more complex ways on rogue planets. Some of these planets could have atmospheres thick with heavy greenhouse gases that are able to trap light and heat in their atmosphere. This energy differential would be large enough to sustain complex life on the surface, even without a sun. The massive amounts of light energy can still reach the planet through interstellar space, and with the right atmospheric conditions, life could potentially flourish on the surface. Since there is no sun to provide light to the planet below, and the atmosphere would likely be thick with clouds, the surface of this planet would likely be pitch black. Whatever creatures of the dark developed on the surface of such a rogue planet would look unlike any kind of life we've ever observed before. Unfortunately, it's extremely difficult to detect the presence of a planet without the aid of a star or other celestial body. Though rogue planets are currently very elusive, scientists are developing ways of detecting them, so that their environments may one day be studied for signs of life. Heikki Vanhamäki, a planetary scientist at the Finnish Meteorological Institute in Helsinki, suggests that if a rogue planet has a moon orbiting it, we could potentially detect auroral emissions from the interaction between the moon and any plasma in the planet's magnetic field. With a large enough radio telescope, this would allow for detection of rogue planets up to 185 light years from Earth. But this is a very short range of sight, and there is no guarantee that a rogue planet will have a moon orbiting it to begin with. If life does exist on rogue planets, then it has picked one of the best places in the universe to hide. So that's 5 areas of the vast universe where life could be hiding. I would love to hear your thoughts on these 5 topics, and more importantly, would love for you to answer the poll on the video. Do you believe there is other life out there? Thanks for watching. Never stop looking up and wondering what could be up there, and I'll see you in the next video.